Good afternoon. This class is dissolved oxygen and alkalinity. These are how to find out dissolved oxygen, how to find out alkalinity in water in first chapter. Yes, first you discuss about alkalinity of water. How can you find out alkalinity of water? Yes, we know this is the conical flask. This is a burette. Yes, source. Yes, we are find out the alkalinity. Yes, requirement operators and solutions for alkalinity. Yes, ACl required 0.02 normality. Phenolphthalein indicator is 1%. Methyl orange is 1%. Baker 50 ml. Dropper is 1 dropper. Conical flask. And this is the burette and stand. This is punner. Yes, this is the magnetic stirrer. This is the magnetic bar. We should using these operators to find out the yes, what about alkalinity in water? Yes, alkalinity water calculate. This is the important thing. Okay, first of all, you should take water. Yes, 50 ml of water in beaker, phenolphthalein indicator, 1 or 2 drops, 2 or 3 drops added to here. 2 or 3 drops added to here. Right. Now, this water color change. The blue color will be changed to pale pink. That is the pink color. Okay, this water, no change of alkalinity, just we are adding indicator. This is the conical flask. This solution enter into conical flask. Okay, next we can take big burette with stand. Okay, this is take some acid 0.02 normality of HCl. It is filled with up to 0. It is filled with up to 0. It is filling. Now we can titration with this solution. This solution. Okay, we keep on magnetic stirrer. This material means this conical flask contain water. Yes, a magnetic bar means we have to stir the this solution. Now adding of acid to water. What happen after some time? This is stirring, adding HCl to the water. The HCl in burette and the water in conical flask. Here what happened? After some time, colorless solution is formed. What happened? Colorless solution. Yes. What happened? Generally, it is a pink color. The pink color is converted into colorless compound. Right. Now we are used 2.5 ml of acid used to pale pink color. Now we calculate total alkalinity equal to mole of acid into 10 ppm. How many moles are acid used? 2.5 ml into 10. What is the value? 2.5. Right? Yes. How much quantity we are used? Total alkalinity equal to how much ml? 2.5 ml into 10 ppm. What is the value? 25 ppm. Total alkalinity of water is 25 ppm. The alkalinity is identified or estimated an unknown solution of water. We don't know how much alkalinity. We should calculate by this experiment. What is the experiment? We should take burette is filled with acid and conical flask in water and indicator, phenolphthalein indicator, 2 or 3 drops added to the water. It is formed the pale pink color. This pale pink color solution is titrated with the, what is that? That is the acid. Titrate chest after that 2.5 ml of acid used titrate into 10 ppm per ml. Now value is 25 ppm. That value is 25 ppm. Right. Now phenolphthalein alkalinity equal to 2.5 into 10. The pale pink, yes, that is the phenolphthalein alkalinity is 25 ppm. Another reagent indicator also there, methyl orange. Okay, same water sample. This is the unknown. We don't know how much alkalinity. We should calculate by using methyl orange indicator. 2 or 3 drops added to this. What happened? The color remains same alkalinity. Yes, it is thick color is formed. Yellow color. This is the yellow color. Now this solution is poured into conical flask and adding what is the solution? Yes, conical. It is burette is filled with 0.2% of acid is filled. Now acid is filled here. What happened? The acid is filled. Okay, up to 0 mark we should take. And again the conical glass solution, the water is stirring on the magnetic stirrer. This is called a magnetic stirrer. This bar is inside magnetic bar. It will stirrer. Stirring means mix of continuously mixing the water. We'll get the colorless compound. What is the color we should take? Yes, adding of HCl to the solution. Adding, stirring. Acid is adding up to 19.5. Yes, mark 19 something. 19 point something will be color is same color is there. Used titrant HCl is 19.6 ml. Now total alkalinity, the mole is used 19.6 into 10 ppm per mole. Methyl orange alkalinity equal to 196 ppm. That is the 196 ppm. What we are discussing here, two things are we are identified. One is the methyl orange alkalinity, another one is phenolphthalein alkalinity. We are using both reagents, both indicators. We should calculate the water alkalinity, water parameter. Water has so many impurities are there. What are the impurities? Hardness causing salts are there. Temporary hardness causing salts, permanent hardness causing salts, and acid is there, base is there. Base is one is alkalinity, acid, acidity, alkalinity, total acid, and the turbidity. Yes, any impurities, any other impurities. Yes, what about calcium? What about magnesium? We should calculate by using these methods. Okay, why? Because some acid required, some base required, more acid, more base. It created not good for drinking, not good for domestic purpose, not used for bathing, not used for any other industry purpose. That's why you should be aware these all parameters of water. Yes, this is a very important things are very yes. This is called alkalinity. Why alkalinity responsible in water? Why? What is the reason behind alkalinity more in water? What are the reason behind? What are the reason behind? Right? Main reason is what? Hydroxide, carbonates, biocarbonates, biocarbonates, hydroxide. These three are very important for the alkalinity. Alkalinity mainly hydroxide, carbonate, bicarbonate. Hydroxide means OH minus, CO3 minus, HCO3 minus. These are the bicarbonates, carbonates, hydroxide and OH minus. CO3 2 minus, that is the carbonate. HCO3 minus, this is the bicarbonates. Bicarbonates, hydroxides, carbonate are the responsible for the, yes, what is that? Alkalinity. Alkalinity is nothing but a base nature of water. Yes, base nature of water. We are using phenolphthalein indicator, methyl orange. We should calculate the what is the value of alkalinity by using titration method. By using titration method. How can you calculate titration method? Adding filled with buried by acid and conical flask is filled with indicator and unknown value of water. We have to take yes titration. First thing is what happened. Yes, titration what happened. Based on colors, we should calculate the values. How much alkalinity in water we should calculate it. This is the one kind of method alkalinity. Why should alkalinity is very important means okay phenolphthalein indicator and these indicators are very important things, right? And resultant conclusion hydroxide, carbonates, bicarbonates. Okay, we should get 2p means yes phenolphthalein indicator, t means yes. Okay, this is the indicator based. We should calculate the how many quantity of methyl orange and phenolphthalein indicator we should calculate, right? This is the one best method for calculation of the alkalinity. Alkalinity calculated. This is the Very best method. Very best method. What you take, I will repeat again. Alkalinity ela calculate chestam. Yes, take conical flask. Right, it is filled. Right. What are the requirement of apparatus? Conical flask, burette, and magnetic stirrer, magnetic stirrer bar. These are the requirement of the apparatus. SCL required 0.01% normality, 1% of phenolphthalein indicator, 1% of methyl orange indicator, and beaker 50 ml of beaker, dropper, and a conical flask, burette and stand, funnel. These are the requirement of the apparatus and magnetic stirrer, magnetic bar. Types of alkalinity, phenolphthalein alkalinity and methyl orange alkalinity. Two types of alkalinities are there. Okay, first we will use phenolphthalein indicator. We get phenolphthalein alkalinity. Now water sample 50 ml and phenolphthalein per 1%. We should take 2 or 3 drops of phenolphthalein indicator in water. Right. Now the blue color is converted into turn into that is blue pale pink color is complete. This is the pale pink. That is a thick pink. No problem. Yeah. Now the solution is pour into conical flask. This is known as a conical flask. Okay. Why should take it? Yes, magnetic bar is inside. Okay. And this is the stand, and it is burette. The solution 0.02 normality of solution in filled with what is that? Filled by this solution. This is called a burette. Now take this conical flask. Yeah, magnetic stirrer. We stir it, magnetic bar, and now stirring the solution. Stirring the solution. Stirring the solution up to color change. Up to color change. Understand? The pink color change. When you are changed, there's some quantity of acid required for the change of color. Right? What is the color change? You will see. What is the color? How to change the color? What is the color? Check it. This is a completely changed. The color will be changed. Some quantity of acid used, 2.5 ml of acid. Okay, now this water sample from groundwater, sea water, river water, canal water, stream water, rainwater, whatever it may be, we collect from outsource water, any source of water. We should calculate the alkalinity. What is the alkalinity of water? We should calculate any unknown water, tap water, any RO water, any distillery water. There is a how much things are there. Definitely we should calculate the anything. Yes, ozonated water. Any water, definitely we should calculate the alkalinity. Yes, how many moles used? How many ml acid used? 2.5 ml into 10. That is value is 25 ppm. How much to ppm? 25 ppm, right? Now we'll use a methyl orange indicator, methyl alkalinity calculator. Same procedure we apply. Just change the instead of phenolphthalein indicator, methyl orange. Okay, this is methyl orange. 2 or 3 drops of methyl orange indicators. Okay, the color is what? Yellow color is formed. Yellow color. The solution completely turned into yellow color. Yes. Now again, yes, acid. This is pour into there. Conical flask filled with water. And next is the burette filled with the acid. How much quantity? The filled with up to 0%. The normality is 0.02 normality of acid is filled. Very interesting. Very interesting. Now the color, what happened? The yellow color, what happened? We will see with magnetic stirrer. Why should you use magnetic stirrer? Stir the complete solution uniformly. That solution is mixing. Right. Now is what happened? Now is acid entry into the conical flask. This is the very completely stirrer. One cheto stirrer cheyali, but not required with the hand. It is the magnetic stirrer is completely, yeah, uniformly stirrer the solution of water with methyl orange. What about next? Yeah, what is the thick color is formed, right? yellow color. Okay. How much quantity? 19.6 ml is methyl orange used. What is the ml of use? 19.6 acid used. How much quantity? 19.6 things, right? Into 10. Now value is the 196 ppm used. This is called the methyl orange alkalinity. Okay, one is the phenolphthalein alkalinity, another one is methyl alkalinity. Yes, main responsible in water. Yes, OH minus, CO3 2 minus, HCO3 minus. These are the main responsible for the alkalinity of water. Why alkalinity? Just a simple reaction in human body. Yes, whenever you feel hungry, your stomach is a little bit burning, right? You should identify why burning in your stomach. Hungry, okay, but in chemical orientation we can explain in chemical reaction why your stomach is burning. Some acid, some quantity of acid released from your master gland, right? Master gland నుంచి ఏం చేస్తుందంటే యాసిడ్ రిలీజ్ అవుతుంది అంటే బ్రెయిన్ నుంచి రిలీజ్ అవుతుంది. Okay, now the acid is entering into your stomach. Whenever your stomach is burning, burning means your empty stomach. Empty stomach means no food is there. Now hungry. If you feel very much hungry, now immediately we should take some quantity of food. Right? We should take a quantity of food. What happened? Yes, it will be neutralized with the acid. మన తిన్న ఫుడ్ కి యాసిడ్ కి ఏమవుతుంది? న్యూట్రలైజ్ అయిపోతుంది. సేమ్ థింగ్ రియాక్షన్. ఇది ఏదైతే మనం ఇక్కడ ఏదైతే చేస్తున్నామో మన స్టమక్ లో కూడా అదే రియాక్షన్ జరుగుతుంది. సేమ్ ఇక్కడ ఈ ఆల్కలినిటీ మనకి ఏం చేస్తుంది? యాసిడ్ న్యూట్రలైజ్ చేస్తున్నారు. అది డైజెస్ట్ సింపుల్లీ ఇట్ విల్ బి డైజెస్టెడ్. ఇట్స్ ఎ వెరీ సింపుల్ రియాక్షన్ ఇన్ హ్యూమన్ బాడీ. Same, that's why in water also some alkalinity, some acidity, some temporary hardness, metals are there. That's mineral water. Mineral water and calcium is required, magnesium is required, and Fe, iron is required, Zn 2 plus also required. These are all metals, all minerals is required in water. That's why this chapter, water treatment, why should we are giving treatment, we are removing these all things, then we utilize the domestic purpose, drinking purpose, and washing purpose, bathing purpose, and industrial purpose, then we should use it. And we are giving treatment of the water. Treatment, treated the water. Treated the water means what? Removing temporary hardness, permanent hardness, so hard particles, alkalinity and turbidity, waste particles, some waste materials also completely removed from the water. That is the very important thing, right? Very important thing. Now, this chapter is today, our topic is alkalinity. Alkalinity, the estimation is over. Next is how much quantity, what are the indicators used, already we discussed. Okay, conical flask, burette, burette stand, magnetic stirrer, magnetic bar. By using these all operators with chemicals, we should calculate the total alkalinity. This is a total alkalinity. What are the main reasons for alkalinity in water? Why should arise? Why should happen alkalinity in water? Main reason is the OH minus, HCO3 minus, and the carbonates also, CO3 2 minus. These are the main causes of the alkalinity of water. This is the very important thing, right? This is the causes of alkalinity. OH minus and CO3 2 minus, HCO3 minus, and OH and CO3 2 minus, CO3 2 minus, and HCO3 minus. These are the main causes of alkalinity in water. This is the main important things. These are the main important. I will repeat again. What is the naming of first one? This is first one is OH minus, and next one is SCO3 2 minus, and next one is HCO3 minus, and next one is OH minus, and CO3 minus 2, and CO3 minus 2, and HCO3 minus. These all are alkalinity is responsible for water. Water లో మనకి alkalinity వస్తుంది. Alkalinity as well basicity. Basicity is very important. Basicity is very important. Basicity is nothing but alkalinity. This is the alkalinity. Alkalinity and basicity. Base, not acid. Okay, this is the very important. The basicity is generated in water, right? These are the main causes of the alkalinity in water, right? And another important is right pH scale. What is pH meter? What is pH scale? Do you know pH scale? Negative logarithm of OH minus ions or negative logarithm of H plus ions, right? Negative logarithm of yes OH minus negative logarithm of H plus ion. Now we should identify here is increasing acid nature. Yes, here increasing base nature. And the base means alkaline. Right. Now is the acid is above 7. Now below 7 is acid nature and above 7 is more base nature. Yes, 8, 9, 10, 11, 12, 13, 14 and 6, 5, 4, 3, 2, 1, 0. Above 7, this is increasing acidic nature. Battery means battery, acid, lemon juice, vinegar. Yes, and here is milk of magnesia, ammonia, like. And this is the 7 is the neutral. 7 is the neutral, right? 7 is neutral. No acid, no base, the spoil, right? This is the important thing. This is the pH scale. This is pH scale. Below the 7 is increasing acidity. Yes, above the alkalinity. Yes, what happened? Increase the basic. Yes, these are the important things. Very important. Yes. Okay, discussion 0, 1, 2, and the more acidic nature. Battery acid. Do you know car battery? There is a 25% of H2SO4 used in the battery. This solution is a battery. What this acid is? What is the pH value? 1. The pH is 1. 2.5. That is the lemon juice. Early morning we take lemon juice. Diluted lemon juice, no problem. The concentrated lemon juice is acidity problem is there. That's why you should not drink early morning. Don't eat apple. Don't eat lemon juice. Don't eat pineapple juice. Don't drink pineapple juice, lemon juice, and apple juice early morning. Why? Because this is acidic nature is more. Acidic nature is more. Okay, that's why you should not drink there. Vinegar also you drink. Yes, that value is 3.3 value. Adult fish died. This adult fish is died. And next value is fish reproduction affected. And larva is affected. This type of values are larvas are affected, died. But coming to this red mark is normal range of precipitation, normal range of stream water. This is the important. And another one is baking soda, seawater. This is the after above the 7. Yes, it is a basic alkalinity. Already we should identify it by the treatment of titration. Sorry, titration with the methyl orange and the phenolphthalein indicator. Yes, baking soda, seawater, milk of magnesia, ammonia, and like right. This is the pH scale. Very important of this pH scale. Okay, this is important of parameter.